one of the concepts that comes into play in physics and in science in general is this idea of significant figures. And I think sometimes it comes up and it's not really explained thoroughly. So I just want to take a few minutes and explain it to you and how it will be used in our class this year. So let's start off with a definition of what it is. Significant figures are the numbers of digits in a measured value that are meaningful. And when I say meaningful, I mean that it's telling me about my instrument. It's telling me about the precision of my measurements and how much I can rely on the numbers shown. There are some instruments that measure very precisely, there are others that do not. And it's easiest to show this just kind of with a basic example of something you might see in a physics class. So let's say I give you a line and I say to you, measure the length of this line. Well, that seems very straightforward, right? You grab yourself a measuring stick. So this is a 1 meter stick. There are 100 centimeters in 1 meter. But notice there's no other markings on this stick other than to know that it is a 1 meter stick. Well, it's pretty difficult to figure out what the measurement of this would be, and whatever measurement I make isn't going to be extremely significant. So how do I write that down? What do I do? Well, the first thing I'm going to do is I'm going to read the value that I know. I know this isn't 1 meter. It's less than 1 meter. So first off, it's going to be 0. It's going to be some part of a meter, so 0 point. And then I'm going to estimate, right? Because I don't know what the next digit is. I'm going to estimate what I think it is. And it looks to me like it might be about 0.2. So that would be my measurement using that 1 meter stick for the length of that line. Now, let's say I get a little more precise and I get a meter stick that looks like this, that's broken up into 10 different sections, right? Into decimeters, if you will. Well, now I know. I'm going to read the value I know. I know that that's definitely 0.2, but I don't know what the next value is. Again, I'm going to have to estimate that next digit, and maybe it's like 2, right? So, or 2 or 3, right? So 0.23 meters then would be the significance of my measurement. Notice as I went from the first to the second, I was able to get more precise with my measurement because my measurement instrument was better. Now, the third meter stick, same sort of meter stick, just with more precise indications on it. So I can read the value that I know. I know it's 0.22. And then I'm going to estimate the next one, right? I know it's more than 2.2. I know it's less than 2.3. It's somewhere in between. So when I estimate the next digit, 0.225. And as I'm going through that, I'm getting more and more precise. My measurements are getting more and more reliable in terms of being able to use them to know what it is the actual length of that line is. Now, I keep saying this word precise and this idea of precision, and sometimes the idea of accuracy and precision get mixed up. So I just want to be very straightforward right here with the difference between the two. Accuracy is talking about measurements that are close to the desired answer, right? I'm trying to figure out what the length of this line is, so I'm trying to get as close as possible to my desired answer. Now, maybe my meter sticks aren't a meter, right? And I gave you this stick and I said, hey, this is a meter, but ultimately, if it's not, my measurement instrument is not calibrated appropriately. No matter what I measure, I'm not going to be accurate towards the actual answer. Precision states that my measurements are close to one another. So as I'm using these measurement instruments, they're getting closer and closer to one another. They're very significantly aligned with one another. They're very precise, okay? Sometimes a picture like this makes that easier to see. Where if I look at the first target, they're just all over the board. Where if I look at the second, I'm true to where I'm supposed to be, which is the center of the target. When I'm precise, I'm close together, right? They're true to themselves. Okay. So significant figures deal with this idea of precision. How precise is my data as I'm going through this? Well, so as I look at this, right, let's say I give you a set of data and I say to you, okay, how precise is this data? How good was this measurement instrument? Well, there's really significant figures are the way to help out. And there's 3 rules for determining how precise my data is or how significant the numbers are within my data. So let's say I have a number that looks like this, okay? The first rule of significant figures is that all non-zero values are significant, Okay, so all these numbers aren't 0. So in that case, this would have 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have 9 significant figures. Okay, that would be how significant that measurement instrument was. Great. Zeros are where it really comes into play. Okay, when we talk about significant figures, because sometimes zeros are placeholders with significant figures. But anytime I have zeros between non-zero digits, those zeros are automatically significant. They play a role. They're a placeholder, kind of, but they're also within the number itself. So I know that they're actually significant. So in this case, this number has 4 significant digits. Now let's say I have some trailing zeros where it looks like they might be placeholders. Well, trailing zeros are significant if they are after the decimal point, because that's telling me I was able to measure out even further and know that it was definitely on that 0, and then I can estimate the next one. Okay, so trailing zeros are significant if they're after the decimal point. This number has 5 significant figures. So let's take a look at some other ones, right? Let's look at this one. 601370. Notice I have a trailing 0, but that trailing 0 is not after my decimal point. There is no decimal point, okay? So that's not a significant digit. It's just a placeholder in place of what's going on. So this number has 5 significant figures. Now, if this had a decimal point at the end of it, 601370 decimal, all of those numbers would be significant because that's telling you when I put the decimal that this is a definite. And I'm assuming there's another 0 on the other side of the decimal. Okay? Let's look at the next one. Oh, if it had a decimal point on the end, all the numbers would be significant. How about that? Okay? Here's another one. Notice I have leading zeros here, not trailing zeros. Leading zeros are not significant. So those are not significant values. So this number would have 6 significant figures. Okay? 60.1370. I have a 0 between other non-zero values, so it's going to be significant. I have a trailing 0 after a decimal point, so that's also going to be significant. So this number, all of those numbers, are going to be significant values. Pretty straightforward, I believe. Okay, what about this one? As I take a look at this, right, I already know right off the bat, there's a lot of zeros there that are trailing, and there is no decimal point whatsoever. So then this number has 5 significant figures. Very good. Boop. Okay. To quick summarize, when we're talking about significant figures are the numbers of digits in a measured value that are meaningful. They're not talking about exact numbers. We're talking about measured values. So exact numbers are things like a dozen eggs is definitely 12. A gross of eggs is definitely 144. Those are exact. When we're talking about significant figures, we're talking about measured values. Exact values they don't have significant figures. Significant figures describe the precision of our measurements and our measurement instrument. Okay? Better measurement instruments means more precise measurements, means more significant figures, means we're closer and closer and closer to one another in our measurements. Significant figures and measurements include what I know plus one estimated value. Remember, I was looking at, okay, this is what I definitely know, and then I estimated the next value to figure it out. There are 3 rules for determining how many significant figures there are in an already measured value, right? Rule number 1, all non-zero values are significant. Rule number 2, zeros between non-zero values are also significant. And rule number 3, trailing zeros are only significant if they're after a decimal point. Well, I know that was quick, and I know I talked fast. Hopefully this gives you the opportunity to know a little bit more about significant values as we move into using them in physics class.